Today we are going to learn about chapter 13 of class 10 science, which is magnetic effects of electric current. Okay, the name suggests that electric current can produce magnetic effects. Okay, that means the current carrying conductors, they are going to behave like a magnet. They produce magnetic field, okay, and show magnetic behavior. Okay, in this chapter we are also going to learn that how we can use this phenomena in our everyday life to make it easy to make certain appliances. Okay, so let's start. Before moving to this particular topic, magnetic effects of electric current, I would like to introduce you some terms related to magnet. Okay, so the very first thing is the definition of magnet itself. Okay, so magnet is what? It is an object. Okay, I can say that magnet is an object which attracts materials like iron, nickel, cobalt. Okay, so magnet is an object which attracts magnetic materials like iron, nickel, cobalt, etc. Okay, what are magnetic materials? Magnetic materials are those materials which, when converted, try to convert into a magnet, they behave like magnet. Okay, so iron, if you take iron and just rub it with a piece of magnet continuously for like 1.5 hours, you will see that the iron itself behaves like a magnet. Okay, so this is a magnetic behavior, like, all right, this is a magnetic material. All right, so magnet is what? An object which attracts magnetic materials like iron, nickel, cobalt. Okay, then how many types of magnets do we have, or we can say that what are the types of magnets? So let's learn types of magnets. Okay, types of magnets. So first we have bar magnet. All right, this is just like a bar, like this. It is having its own north pole and south pole. So this is what a bar magnet looks like. The second one is U-shaped magnet. Okay, U-shaped magnet. The name itself suggests that a magnet which is having a shape of English alphabet U. Okay, so this is something like this. It is one end is behaving like a north pole and the other end is behaving like a south pole. So this is what U-shaped magnet looks like. All right, then the third one we have horseshoe magnet. Okay, now what is the difference between a U-shaped magnet and horseshoe magnet? Look at this shape of these two. So horseshoe magnet is something like this. The ends are quite close to each other. Okay, this is a horseshoe magnet. One end behaves like a north pole and the other end behaves like a south pole. All right, then the fourth type of magnet we have is disc magnet. Okay, disc magnet, a magnet which is having a shape of disc, just like this. All right, so this is a disc. Now where are the north and south poles in such kind of magnets? So this upper surface of the disc, this behaves as a north pole or maybe south pole. Okay, and the lower surface, this behaves as the opposite pole. If upper surface is north, then the lower surface acts as south pole, or if the upper surface is south, then the lower surface behaves as south pole. Okay, so lower surface and upper surface, they behave as opposite poles. Okay, then next we have ring magnets. Fifth one is ring magnets. Now what are ring magnets? They are in the shape of a ring, just like this. Okay, if I take the 3D model, it looks like something like this. Okay, so this is a ring. All right, such type of magnets are ring magnets. Now the question arises that where are the north poles and south poles of such magnets lying? Okay, where are the poles of this magnet? So there are two cases, two possibilities. One is that let's just draw another ring so that we can understand this better. Okay, so this is another ring. All right, so there might be a possibility that in some cases, you know, the upper part of this ring behaves as one pole and the lower surface that behaves as the other pole. Okay, so this is something like you can just show it like this. No, I'm sorry, the direction is something like this, north to south. All right, so we can show it like this. Okay, so one possibility is that upper surface and lower surface, they both behave as opposite poles. The other possibility is that one half of the ring behaves as north pole and the other half of the ring behaves as south pole. Okay, so this is diametrically, when you are saying that half of the ring, this half of the ring is behaving like a north pole and this half of the ring is behaving like south pole, we can say that diametrically half of the ring behaves as north pole and the half of ring behaves as south pole. All right, so this is how ring magnets have their north and south poles. The other kind of magnet we have is needle magnet. Okay, needle magnets, they are needle shaped, something just like kind of this type of magnet, needle shaped. Okay, so half of the needle behaves as north pole and the half of needle behaves like a south pole. Okay, so these are some types of magnets which are normally used in day-to-day life. All right, okay, so in this chapter we are going to consider only the bar magnet because we are going to compare the current carrying conductor with a bar magnet. All right, so let's take the definition of bar magnet. Now what is bar magnet? Let's understand. A bar magnet is nothing but a rectangular bar. Okay, what is this? A rectangular bar with uniform cross section. Okay, so the condition is that it must have uniform cross section. Okay, it exhibits magnetic properties and attracts pieces of iron. So the other condition is that it exhibits magnetic properties, and attracts pieces of iron. Okay, normally if I show you, this is how a bar magnet looks like. Okay, so these cross sections should be uniform throughout. Okay, and it should be rectangular. It is rectangular obviously. Okay, and then it shows magnetic properties, like it is having north pole and south pole, then there are magnetic fields around it. Okay, there should be a magnetic field around it. Okay, and it should attract pieces of iron. Iron is magnetic material, right? So this is how we define a bar magnet. Now when we are talking about magnetic properties, what are these magnetic properties? Okay, let's just discuss them, the properties of a bar magnet. So the next topic is properties of a bar magnet. Okay, what are these properties? Now the first property is that when you tie this bar magnet with a thread, okay, and then you suspend it, you just tie the other end of the thread, so the two ends of magnet, they align themselves when suspended freely. When the bar magnet is suspended freely, its two ends align themselves in a particular direction such that one end aligns in north pole, along the north pole of earth, and the other end aligns towards the south pole of the earth. Okay, so this is how a bar magnet aligns itself when it is suspended freely. Okay, so we can say that this particular end, if it is towards the north, we call it north seeking end, north seeking pole, or in general we can say that it is a north pole of the magnet. Okay, now this particular end which aligns itself towards south pole, we call it south seeking pole, or just simply south pole. Okay, so this is the first property of bar magnet. Let's see another property of bar magnet. Okay, you see that there are two poles of a magnet. We saw that, right? One pole aligns itself toward the north pole of earth and the other pole aligns itself toward the south pole of. Okay, so the other properties related to these poles, it says that the two poles of magnet, if they are like, they repel each other. Okay, so let's just understand with this diagram. We have bar magnets like this. Okay, now we have such type of alignment of the bar magnets. Okay, when two bar magnets come close to each other and the two ends which are quite close to each other, if they are like, then there will be repulsion between those two poles. Okay, so we can say that like poles of magnet repel each other. This is the another property of bar magnet. Like the north and north pole, when they come close to each other, they also repel each other. There will be repulsion. Okay. On the other hand, if you bring two opposite ends of magnets close to each other, they attract. Okay. So we can take this example, like we have north and south pole of two magnets. Now these two ends are opposite. These two ends are unlike, north and south. So there will be attraction. Okay. So we can say that unlike poles of a magnet attract each other.